Alrighty, so I wanted to do a video here on solving exponential equations when we cannot match the base. There are many ways you can do this. I'm just going to run through two here, and we'll see that our answers can look different. So I'm always going to ask us to condense our answers to one logarithm, and even then we might see kind of some properties or some ways that we would be able to identify that we have the same answer. So the first thing I'm going to do is take a log of both sides. You can choose any log. If we were using the calculator to check at the end, a common log or a natural log would be the easiest. So I'm going to choose to use natural log here just because it's less letters to write. So I'm going to take a natural log of both sides. And once we have those logarithms, I can then move the exponents out front. So I'm going to get this 2x plus 4, and notice these parentheses. They're very important. That whole thing would be multiplied to the natural log of 6 equals the quantity negative x plus 1 all times natural log of 5. So now our variables are on our main line of the equation, and we can start solving. So I am going to distribute the natural logs, and this is the step where students will usually kind of mix things up. I do see a lot of students divide, like that negative x plus 1 to the other side, and then divide the log to the other side, but we won't be able to get x alone. So I'm going to distribute these natural logs into our parentheses. And of course, I wrote the wrong thing. 4 natural log of 6, negative x, natural log of 5, plus 1 natural log of 5. And now I can move any terms with an x to the same side, and anything that does not have an x, I'll move to the right side. Okay, so now I can factor out the x on the left and get this guy, which I'm going to divide over. So once we are at this step, and I'm just going to be a little lazy and I'll cross it out over here and just divide over to the other side, our directions are going to be condensed to one logarithm. But if we were using a calculator, you could right here get an approximation of what x equals because we have x alone. But I'm going to start condensing by moving any coefficient. So like this 4, I'm going to move to our exponent, and same thing in the denominator. This would be 6 squared, so I'm just going to write natural log of 36 and natural log of 5. So now that we don't have any coefficients, we can combine our addition and subtraction. So up in the numerator, it's subtraction, so I'm going to divide 5 over 6 to the 4th. In my denominator, I'm going to multiply 36 times 5, and then using change of base, I can write this as one logarithm. So my denominator, 36 times 5, would be my base. And you can multiply that out, but I don't have a calculator on me, so I'm just going to leave it. And my argument would be 5 divided by 6 to the 4th. And again, we can leave it just like that. So this is one logarithm as our answer. Now there are other possible answers. I'm going to do the next slide, but if you guys want to try out some on your own, you can go from here. So if you see another answer, you might have to check if it's equivalent or explore why that might be different. So I'm going to do the same problem one more time, a different method. But if you guys are good to go, feel free to try out some more. So I'm going to add a new slide here, if I remember how. Not that one. There we go. And I'm going to do that same problem one more time. I'm actually going to have it kind of fast forward through here. All right, so like I said, doing the same problem, I'm going to kind of breeze through this one. You guys can feel free to pause the video. So on the last page, I took natural log. Now I'm going to choose one of these bases, and I'm going to use that as my base. So I have log 6 on the left, log 6 on the right, which means my left side will just be that exponent. And my right side, I moved the exponent out front. So now I'm going to do a very similar method. I'm going to distribute the log 6 of 5, move my x's to the same side, and factor it out, and then get x alone. So I know I kind of let that speed run through, but going through. So again, my answer looks different than the last slide, but if you put that in the calculator, you get the same approximation. Our directions will be condensed to one logarithm. So now I'm going to work on condensing. I'm going to put logarithms in for all those constants. And then I like to move all coefficients up. So even -1, I'm going to take to my exponents. Condense using multiplication and division. And again, take your time if you're not sure how I got this. I would write out even more steps. We can see this method seems a little bit lengthier for now. And then finally, using change of base, I can write this as 1 logarithm. So if you go back to the first example, I actually have both reciprocals in the base and the argument, but kind of interesting log property, they will be equivalent. So you guys might see that for some answers. So some more examples on these to try out. Feel free to give those a try and let me know any questions.